So welcome, I'm Hosuk Won, Technical Marketing Engineer within the Enterprise Networking and the Cloud team. So I'll be guiding you through the Infrastructure as Code, the IAC with ISE. So one thing that is different with today's session from the previous ones is that I'll spend more time with the demo than slides. So expect about 15 minutes of slides to explain why the IAC, and then we'll dive right into the actual demo. The demo will consist of using Terraform to deploy services in the AWS, like instance bringing up for ISE, and then we'll use the Ansible to configure policies on ISE. Lastly, we will do some basic radius testing to confirm the setup is working as intended, and then we'll have some time for Q&A. So why infrastructure as code? So let's focus on the code part. So when you look at the developer community, the engineering, they went through pains of solving the problem of collaboration around large projects. So when you're developing a software large like ISE that consists of hundreds of developers, there are going to be conflicts and bugs introduced due to the complexity and large number of developers. So the way that we are addressing it, or developer communities are addressing it, is using versioning. So like using the tools like Git, that allows one to have a main branch and at the same time branch off a different code, and then work on it and create a feature on that code, and then merge it back to the main branch. And doing so, in case there is a conflict of a file that's been modified by multiple engineers, that can be looked into before merging them. The other part is the accountability. Because you're using the versioning with Git, that means that you know exactly who the user is and what time that they actually modify the file, and you can have a diff version, different views on what the changes were between the original file and the changes that was made by the user. And that also provides security, because before you commit the changes, now everyone can see what the changes were before making it to the actual main branch. Also, one of the kind of a concept of the programming is the reusability of the code. So anytime there's a repeating code, usually they create modules, and then they reuse it over and over again without having to copy and paste the same code into the actual code. And that also allows you to speed up the process of the development, because many times you don't have to create the same code that does the same thing. And the other benefit is the automation. Automation means once you have a setup of the code, you can easily deploy it. And at the same time, many of the best practices around the code development is to make sure that as you develop the code or modules, make sure that you also develop the testing part of it. So if your code block that you're developing as an engineer, you're expecting the code to do certain actions, you're actually asked to create a testing plan for that, so that when the code is built, the testing can be also followed up to make sure that it is working as intended. And if you think about this testing part, this same thing can be applied to infrastructure as code. So as you make changes to your network, and if you expect that there's a new subnet or new infrastructure you're setting it up, and then that means that you can also confirm that the network is running as expected by creating test cases on your own. The last but not least is the documentation. As you know, when you're creating programs, you also have remarks that you add into the programs to show what the code block is doing. And of course, you also have to have wiki pages to augment that document, the actual programs. But in general, many of the well-built codes will kind of tell the user when they're reading it, show the what the code is going to be doing. And this is also important for the infrastructure as code as well, because you can actually kind of describe what your intention is when you're creating configurations. Now, kind of shifting the focus from the kind of a code development as a developer to the actual infrastructure, right? So if you look at the traditional infrastructure, there are changes that let's say you have to make. That means that you have to create a ticket, and now you have to submit it, and someone else is going to, in the operation team, will make the changes during the maintenance window, right? They'll be using some console, maybe clicking on things on the GUI, or maybe using the CLI, but those changes will be made. However, these kind of small changes, right? It's okay if you have a relatively small environment. However, if you have a large enterprise, the software gets more complex, and with added scale requirements, this will become very hard to manage. So that's why the infrastructure as code is very important. And the main key thing is reusing many of the best practices that's been used by the developers and applying that to the actual operations of the network management and deployment. So if you want to learn more about the infrastructure as code, which applies to the API and the Ansible and the automation on ISE, there are 2 sessions my colleague Thomas Howard did previously in this year. So check out the ISE APIs and Ansible and automation session, as well as the ISE REST API session. And you can go to this short URL. And the other news is if you are interested in pursuing this as a career, Cisco has something called DevNet, which has a whole bunch of resources around the how to do a DevOps for the networking, including the ISE. And we even have certifications around this. So there's the associate level, which is the CCNA equivalent. There's the professional for the CCNP equivalent. And we just introduced a expert level, which is equivalent of the CCIE. So you can check out the DevNet in this link for ISE. Okay, so having said that, let's now put the focus back to the ISE. So before we can talk about the infrastructure as code, I want to kind of describe how you would install ISE in the infrastructure, right? And in this case, I'm going to showing you an example of AWS. However, this doesn't have to be AWS. You can do this same for the on-prem network. Instead of the AWS cloud, it will be like a VMware, along with some F5 load balancer and maybe info blocks for DNS. But you can still do the same thing, except for demonstration purposes, AWS is much easier because everything around the DNS services and the load balancer and the network components are already in the single GUI, and I can show you easily what has been done. So when you're installing the ISE in AWS, first thing that you need to do is decide on which region that you're going to deploy ISE into. And once that's done, you're going to decide which availability zones within the region that you're going to be using. And you're going to create the VPC, the virtual private cloud, and the subnets that ISE will be brought up. And then you'll create the security groups to control what access will be allowed into the ISE instances that you're bringing up. And then you'll decide on instance type that dictates, how many endpoints that you're going to be supporting with ISE. And importantly, you need to set up the VPN, right? So if you have on-prem network devices and the users on the actual office, it needs to have a secure connection back to the VPC. So it could be VPN, it could be a direct connect, but you need some secure connectivity to make sure that the radius traffic is encrypted. So once you have the underlying network set up, the next step is to bring up the ISE. So for ISE, you can easily go to the AWS Marketplace and just search for Cisco ISE, or you can just go to the short link here, and you'll be greeted with the ISE page within the AWS Marketplace. You can just click on Continue to Subscribe. And then at some point, you'll have a page where you have to enter in all the basic information about the ISE installation that you're bringing up. So you'll have a stack name, you'll have the host name, and then the IP address that you want to assign, as well as the subnets. And then there are other settings like DNS IP addresses, the DNS host names, domain name, and the admin password. So when you're setting it up one by one, it's going to take about 5 minutes to go through all this process. And it's going to take about 30 minutes for the ISE to actually come up and present to you with the actual GUI. So this is easy when you have like a single devices to bring up. So what are the other options to bring up ISE? So I just talked about the AWS Marketplace, and there's something called the AWS CloudFormation template. In fact, when I was showing that GUI in the previous screen, we were actually using the CloudFormation template. So it provides a guideline of what inputs that you need to provide during the ISE installation. And it's kind of easier than kind of, using the AMI machine image in a raw manner, because it provides all the things that you need to have before it lets you proceed to the next kind of stage. And for instance, there are some password requirement that ISE has when you're using the admin passwords, and it will make sure that all those passwords you're entering in conforms to the whatever ISE requires before letting you install the ISE, so that when you actually bring up the ISE, it is up and running instead of in a non-working state. So again, if you're using these, bring up ISE one by one, the best way is to use the AWS Marketplace, and in the backend, it is actually using the CloudFormation template. However, if you're using the GovCloud, then in that case, you're kind of stuck with using the AMI. But what if you want to bring up more than just one node? What if you want to bring up like 20 nodes or 50 nodes? This is where the infrastructure as code shines. I'm going to do a demo on using both Terraform and Ansible, but this is where you can bring up 20 nodes or 50 nodes in a relatively short manner, and also make sure that all the settings that you're bringing up is something that you are expected and have been tested throughout your deployment process. So with that, Rigo, can you give us the answers from the previous poll question?
Yeah, absolutely. Thank you, Hosuk. All right, so let's take a look here. And just as a reminder, for the first question, we asked, where are you planning to host ISE nodes? And based on the results, it shows that the overwhelming majority is looking to host ISE nodes in on-premises hypervisor. So that was the number one answer.
Mm-hmm. Okay. And let's go to the next question. So which infrastructure as code tools do you use, or are you using on your network? So there's the Ansible, Chef, Puppet, Terraform. Maybe you may be using multiple tools, or maybe you're using something else. Okay, so let's move on to the next section. So, we talked about the infrastructure as code tools a bit, but I'm going to talk about some of the what's called the third-party infrastructure as code tools. So when I say third-party, it means that if you look at the AWS, it comes with its own IAC tool called CloudFormation template. If you use Azure Cloud, it has something called Azure Resource Manager. And same for Google, it has something called Cloud Deployment Manager. These are the actual IAC tools that each of the provider provides, so that customer can utilize these languages to deploy their infrastructure in each of the respective public clouds. But what about the other environments, right? You're not only going to have these public clouds, you may have multiple of them, or you may have the on-prem network using Cisco devices, Meraki devices, or you may even have some other cloud services that may not be using these languages. So that's why the third-party tools like Terraform and Ansible becomes very useful, because when you're trying to find resources to be able to support these networks, the Terraform and Ansible has all the plugins to support any kinds of public cloud, as well as the on-premises resources like Cisco, Oracle, or even VMware. So, like when you're trying to find engineer to support the DevOps on your network, right? You may find who's really familiar with AWS, but not with Azure. However, if you find someone who's familiar with either Terraform or Ansible, and then you know that it can be compatible with any number of cloud vendors out there. So it's much useful by using these tools. So let's just do a quick comparison between the Terraform and Ansible. When I say characteristics, I'm going to explain a little bit better when I show you the actual demo and the configurations. But there's a term called the declarative. And what that means is that when you configure a IAC tools like Terraform, and you say, hey, I'm going to have a instance up and running, that's the only thing that you need. You don't have to worry about how to bring up a instance in the AWS or whatever cloud platform. You just want to have an instance brought up. You make a configuration, and the Terraform will make sure that all the dependencies are in place and then your instance can come up. You don't have to, worry about what are the actual steps to get that, instance running. So it takes care of all the complexities that precedes the actual like a final state of the things that you want, and that's what we call declarative. The antonym of the declarative would be procedural, meaning that when you want to achieve something, you need to make sure that all the prerequisites has to be completed before the final state is done. So if you're bringing up an instance and there are a few steps that you need to do beforehand, like bring up the network interface, bring up the disk volumes, and you have to do that before the actual instance, and then that means that it's procedural, right? Because you need to make sure that those are done before you can actually bring up the instance. So the difference between the two is that Terraform is very, very declarative, meaning that you want something and it's been defined, and it will make sure that that state or that device or instance is up and running. Ansible does some of that part, but when Ansible started, it was not a API-driven product. So many times you'll notice that there is some procedural aspect of it as you use Ansible. So that's why I kind of noted that it's kind of both declarative and the procedural. And the bigger kind of difference is that Terraform is much better at infrastructure provisioning. So when you're setting up the VPC, the subnets, it is really good. And at the same time, one of the difference that it has between the Terraform and other tools is that it maintains the state of the things that it has deployed. So when you try to run the Terraform, the code again, it's not going to apply the same set of VPC or subnets that you created before. It's going to say, hey, I confirm with the state file that I have. It turns out that you already have all the things that you were asking me before, and I'm not going to re-add those resources again. So I'll show you real quick what that looks like. Ansible does some of the infrastructure provisioning as well. So anything that I'm showing you today can be done by either Terraform or Ansible, but it is much better at configuration management. So that's why in the demo today, I'm going to show you how Ansible can configure ISE policies as well as like joining the ISE deployment. Community-wise, Terraform is much younger. Ansible has been there for a while, so it has a lot of community support. There are some language differences between the Terraform and Ansible, and of course, it's from different company. So Terraform is made by HashiCorp, whereas Ansible is made by Red Hat. Okay, so let's move into the actual demo part. So previously we looked at the two kind of steps, right? We talked about how to set up the underlying networks. We also showed you how to bring up a single instance, but that's not all, right? When you have a large scale ISE deployment, there are other things that you also need to complete before it can actually serve the actual users and the authentications from network devices. So you need DNS entries. So if you have deployed ISE for a long time, you may know that it needs not only the forward zone entries, but it also needs the reverse zone entries, which means that you have to be able to ping the IP address and get the actual name of the host. If you have more than 2 ISE nodes, you probably want to invest in load balancer. And if you want to make backups of the ISE configurations or the policies, you have to configure a ISE repository. So this part, I'm going to show you using the what was done by Terraform because it takes some time for ISE to come up. I've already pre-configured it and brought it up about 30 minutes ago, and it's up and running. And I'll show you what has been done by Terraform. However, the next part, I'm going to show you dynamically. So the Ansible is going to take over from the Terraform, and it will configure the repository that's been configured by Terraform. The other part is it's also going to work with the digital certificates. And I have some interesting protocol that I'm kind of embedded into the demo using what's called the ACME protocol, the Automated Certificate Management Environment Protocol. And it uses the APIs with the open CA, such as Let's Encrypt, to get a certificate using the APIs. And I'll show you how we get the certificates and what the process looks like, and how we're going to import into the ISE for well-known CA for guest access and the posture assessment. using the Ansible. And then I'll import the network devices that I'm using in my lab. And we'll also use Ansible to join the AD. So it will join the AD, and it will also, retrieve some groups as well as some attributes for the users. And we'll also test, create some test user accounts and the groups within the ISE internal database. And of course, nothing's going to work until we have a policies, right? So we will leverage the new ISE 3.1 API, where we can actually create policy sets. And then lastly, we'll actually form a deployment between the 5 nodes that we have. Okay, so just to show you what the demo looks like. So we have the AWS Cloud, actually using the US East, US West 2. In case you haven't heard, this morning in the US time, we had an outage with the AWS, and actually impacted my demo on the another session. I was not able to show everything around the demonstration I was going to do. But hopefully, we're using a different zone, a region this time, the US West 2. I've changed it so that I can make sure that there's no issues running the demo today. But it's even the cloud sometimes have issues, right? So I'm going to use the US West 2. And I have a VPC that's set up with the 10.0.00/16 CIDR. And within that VPC, I have 2 availability zones with these, each corresponding subnets. So subnet 1 will have 10.0.1.0/24, and the subnet 2 will have 10.0.2.0. There's also an internet gateway that I have configured so that the ISE can reach out to the internet or Cisco.com to get any updates for posture and profiling purposes. And I'm also having a VPN gateway set up with the access to the on-prem network. So we have a on-prem network that runs the 192.168.0.0/16. And this is where I have some test equipment as well as the network devices and the clients. Of course, I have these security groups so I can control what access are given to the instances I'm bringing up. And I am bringing up 6 nodes. So there's the 3 nodes in the subnet 1, the primary admin node, primary MNT, and 2 PSNs for redundancy. And then on the subnet 2, I have a secondary admin node and secondary MNT, and 2 PSN node. But in the actual demo, you'll only see 1 PSN in the subnet 2 because we had some bug where if one of the self-signed certificate has some certain like a strings, like actually 3+ signs in a row, it can't be imported into the ISE using the API. So I was not able to add this one into the deployment when I checked. So I only have like 5 nodes in there. So if you see 5 nodes instead of 6, that is because one of the nodes was kind of impacted by the bug. But the last part is the actual DNS and the load balancer, right? So I'm using dynamic IP addresses on all these nodes. So because they need to see each other, I have IP addresses dynamically added using the Route 53. And I have the network load balancer load balancing the radius, authentication, accounting, and the TACX plus traffic on all 3 or 4 PSN nodes. Okay, so with that, let's jump into the actual demo. But before I move to the demo, Rico, can you give us a result of the previous poll question?
Yeah, absolutely. So for the second poll, the question was, which LAC tools do you use? And in looking at the answers here, we actually have 2 ties. So for the top answer, Ansible and Terraform had the same number of votes, so that's number 1. And then for our second top answer, and also our second tie, our participants went with multiple tools and other.
Oh, that's awesome. So I'm going to show you both Terraform and Ansible, and also the case of multiple tools. And I'll show you how the handoff between the Terraform and Ansible is achieved. So I'm going to go really quick on this, but this is a demo configuration file that I have for Terraform. And I'm just showing you what has been done already. But there is a remark, like I'm creating a VPC, and you have I start with the resource, and the actual resource type. In this case, it's going to be a AWS VPC. and I have a name that I can give, and it can be any name. And then I have the actual attributes that is, either mandatory or optional. So like CIDR block will be mandatory. The tags and anything else will be optional. So I have some, DNS is enabled, yes. And just you can look at the other configuration blocks in the same way. So I'm creating a VPC called main, and I'm also configuring the internet gateway so that I have internet access. And then I have some route table that I have configured so I can route traffic within the VPC and outside through the VPN. And then I have two subnets. Subnet 1 that runs on US West 2A availability zone, and subnet 2 that is on US West 2B availability zone, so that we have redundancy. And then we have the security group that controls what traffic is allowed onto the ISE instance that we're bringing up. And then I'm creating a load balancer. So unlike the instances I'm bringing up, for the load balancer, I'm going to be using static IP so that these can be hard-coded into network devices, regardless of what dynamic IP addresses are being used on the actual PSN nodes. So just in case you didn't know, many of the cloud providers, AWS and Azure Cloud, they reserve some of the some IP addresses. So like first three IPs, 1, 2, and 3 is reserved. So I'm using the 4 as the first IP address that I'm statically assigning. The other part is I'm using the ISE repository, or I'm setting up the ISE repository using the S3 bucket. So I'm using some service called the AWS Transfer Family, and I enable the SFTP service so that ISE can like make backups to the S3 bucket that we have created. And at the same time, I'm actually creating a user that ISE can use. And later on, I'm going to take these as a variable and create the actual user account on ISE so that we're going to use this to make backups if you need to. And then the other part is there. But the important part is the actual instance bring up, right? So I have admin and MNT in zone A with count 1. So this is a medium deployment where the admin and MNT are collapsed. And I have the AMI, which is the Amazon machine image for that region. And I have 1.2 terabytes for the volume size. And I have the instance type, which is M5 4x large. Now, instance type is what dictates how much core of the CPU you have and how much memory, RAM that you're going to assign. And you'll notice that these are different depending on it's a admin function or the PSN function. And then I have the DNS zones defined so that these dynamic IP addresses can be registered to the forward zone and the reverse zone. And I'm repeating that for the secondary admin MT in zone B. And then for the two PSNs, I'm again creating on the zone A, and I have count of 2. I'm using the same AMI and with a smaller volume size because it's a PSN, it doesn't require that much hard drive space. And again, I'm using a different instance type in this case, which is the C5 4x large instead of the M5. And this has a less CPU core and memory, but it has a faster CPU, so it's more adequate. It works better for the PSN function. The other parts are the same, but only thing that I'm adding on top of that is the target group. So this is for the load balancer setup. Since PSNs will be participating in load balancing the Radius and the TACX Plus, and that's why the PSNs has these entries in there, while the admin and the MNT node doesn't. And again, I'm repeating it for the zone B, so I have redundancy of 2 PSNs in zone B. And then scrolling down, once this is done, I'm going to print out all the IP addresses that I have assigned. And if you look on the right-hand side, that's what I have just printed out. So all the dynamic IP addresses that's been assigned for the admin node and the PSN nodes, as you can see, now I have the IP addresses in there. And then, the question becomes, okay, now we have, brought up all these things, with Terraform. How does the Ansible know about these dynamic IP addresses, right? So here's the trick. I'm going to create a Ansible variables file using the Terraform, process. So this code block is going to create a actual variables file with all the the dynamic IPs that I have created and it's going to place it into the Ansible folder. So the Ansible process can pick it up and use all the dynamic IPs I've assigned. So let me just show you what that looks like. So this is the template file. So as you can see, these are all the variables that I'm defining, that I'm entering in. And the end result of the actual variable file that we use is this. So you created using the deployment type, all the variables like username and password, as well as the SFTP URL and the IP addresses of all the hosts. And again, this will be picked up by the Ansible process. Okay, so now that we have shown you this, let me jump into the AWS console and show you what has been done. So starting with the EC2, so there are the 6 ISE nodes. Let me sort them. And as you can see, we have the 2 M5 for admin enmity and the 4 PSNs running the C5 4XLRs with the different IP addresses. And if you go to load balancers, here's the load balancer, it's active. And here are the 2 static IPs for each of the subnets. And if you go to the target groups, you'll see that we are serving the radius 1812, 1813 for accounting, as well as the TACX Plus. And you can also see the health status of these nodes in there. So you can see that 4 nodes are healthy state in the setup. Just to let you know, the AWS load balancer is kind of limited in terms of how to check for the healthy state of these nodes. So what I'm actually doing is just looking into TCP 443 instead of actually sending a proper radius authentication traffic. So, what that means is that it's not actually checking for radius services or TACX service. I'm just merely making sure that there's a web service running on the port 443 for admin function, and I'm kind of implying that the service is up and running. If you want more tighter integration between the health check, then you'll need to use a third-party load balancer like F5. The other services that we have done, of course, we have the VPC, which has the subnets, but let me just show you the S3 bucket that's been created. So this is the SFTP services that's been set up, and there is the different IP addresses for different subnets, and this is the user that's been created along with the S3 bucket. And then lastly, I'll show you the DNS entries. So I have 3 zones. There are 2 of them are private. So if you look at the main private zone, you'll notice that there's the ISE 1 through 6 with respective IP addresses. And you also see the reverse zone defined as well. So here's the IP addresses and the actual host names. Okay, so with that, let's actually log into the ISE node. So I'm going to just click on the first node. Okay, so it's up and running. That's good. Okay, so this is a first time logging in, so there shouldn't be any data in this setup, but I'll just confirm. Okay, so this is new setup. And, as you can see, there's no policies, should be empty. So there's only one default policy, and there's the no users setup. And as you can see, there's no AD setup, right? This is a kind of pristine setup of ISE at this point. And network devices hasn't been defined yet. And if you go to certificates, you'll notice that the default self-signed certificate is being used for everything, right? The admin, the radius, and the EAP, and the portal pages. And lastly, if you go to deployment, there's only one node, and it's in the standalone role for now. But as I go through the Ansible playbook, it's going to change it and then make it into a primary role so you can accept the other connections. So at this point, let's go back to the slide deck. So before I show you the rest of the demo, what I'm going to do is use the ACME protocol to actually get a publicly assigned certificate using the Let's Encrypt OpenCA. The way the automated certificate management environment, the ACME protocol works is that the admin, whether it's automated or manual, is going to send a certificate signing request to the OpenCA. In this case, will be the Let's Encrypt. And the main way to, OpenCA has to confirm that you actually own the domain, right? You have a full access to your domain. Like in this case, I have a domain called authc.net. A way to confirm that is if I have full access to the domain, that means that if I have a web server in that domain, I should be able to place a file in some directory with a certain file name or a certain file content in that directory. And if the OpenCA can send a string of the file name, and if it can confirm that file name is in there, it can infer that I do have full domain access. And then it will issue a certificate to me. This is nice, but it doesn't work for ISE, right? Because it implies that your web server is hosted on the DMZ or internet, right? Where anyone can get to it, so that you can get the, check out the proof of ownership of that domain. And in general, you wouldn't have the ISE kind of exposed to the DMZ or internet, so this would not work. So the second option is using DNS. So the way it works is that OpenCA will instruct the user, either automatically or manually, add an entry in the DNS zone. Add a record, it's a text record with certain string. And if that string matches what the OpenCA requested, then it's going to issue a signed certificate. So this works with ISE because in this case, ISE does not have to be exposed. And I'll show you how this is done using the Route 53 DNS server. Okay, so going back to the code. Now, OpenCA with the Let's Encrypt, a lot of times they're very busy. So if it takes a longer time than expected, then I'm going to revert back to their staging server. But I just want to show you what the experience looks like. So I'm going to run the process. Okay, so as you can see, it's using CA server, ACME, and then it's trying to get a wildcard certificate for the star.authc.net. And if you see that add text value, right? So this is the actual value that it's going to, that it's like a password that it's asking me to add to my DNS server. So if I hop back into my Route 53, if I go to the public zone of my authc.net, you can see that text value is in there, right? So ECQ4, and it added it in there. And then it's going to now do a DNS lookup, NS lookup to find out if that matching entry exists. And if it does, then it knows that I own the domain, and it's going to issue the certificate for me. Okay, so now it has been added. So it's now checking for that challenge. And it has some timeout values because you can imagine this being a free services. There are a lot of users, trying this service. And like I said, sometimes it fails because it's busy. And they usually recommend, doing this in a non-busy hour or every 60 days so that you can always renew within that time frame. So in case you didn't know, they only give out certificates that's valid for 90 days. Okay, I'm gonna let it cycle at least one time and see what happens. If it doesn't work, again, I'm going to revert back to the staging server to show you what the experience looks like as a whole. Okay, yeah, so it's timing out. It's kind of busy. Let me just wait for this to expire. Okay. What I'm going to do is I'm going to switch back to the staging. Okay, and let's run this again. Okay, so I'm using a staging server from the Let's Encrypt, and this will be much faster. So as you can see, we just got the signed certificate from the Let's Encrypt. And the next part is rest of the Ansible playbook. And just to explain the Ansible playbook, there's some kind of the main part, and this whole thing, the playbook is going to be an ISE demo. And you'll notice that compared to the HashiCorp's the Terraform configuration, this is much readable because it's using a YAML format. But it's going to get the variables file that we have created using the Terraform, right? So this is where it's defined. And then there are also other variables that we're defining, such as the host name, username, and password. And we're using something called the YAML anchoring. So anything that you see with this ampersand and below is kind of anchored back here using the star and ISE login. So we, instead of showing these 5 or 6 lines repeatedly within the code blocks, I'm just replacing them with this one-liner. So you have to, the code is more compact. But the first part that we're doing here is importing all the root cert of the Let's Encrypt, as well as the intermediate cert and the actual wildcard certificate that we have got issued from the Let's Encrypt. Once that's done, I'm going to add the S3 as a repository. Remember that we have a username called a SFTP user and the path. We are just redefining here so that ISE knows about repository so they can use it for the actual backups. And then next section is just adding the AD. So I'm adding the ISE to the, or joining to the Cisco.com. Obviously, I don't have access to Cisco.com, so I won't be able to join, but it will be present. The other part is the authc.net. I do have access to the authc.net, so you'll see that it will be joined properly to that domain. Then I'll also grab some of the groups as well as some of the attributes for the users in there. And then I'll add some network devices. So I have some test devices on my network that I'll be adding, such as Catalyst 9800, the Meraki devices, as well as some third-party devices. And then once that's done, I'm also creating some internal users and groups for testing purposes. And then I'm going to finally create the policies. So this is where I'm creating VPN policies, as well as the wireless policy and the wired policy sets, so that can be used for the authentication. So again, this was a new feature we have added on the ISE 3.1 API, where you can now control the policies using the API calls. But the last part I want to show you that's really exciting is the deployment piece. So like I mentioned, we have the 6 nodes. In fact, only 5 nodes because one of them, kind of met the bug around the certificates. So we have, 5 nodes that's going to be kind of joined into a single domain. So first thing that it's going to do is make sure that all the nodes are in a standalone state. And then once that's done, it's going to export the certificate from the secondary nodes and import them one by one to the primary node so it can be trusted. And again, here's the one that I have remarked because of the defect. And then once that's done, I'm going to promote the primary node from standalone to the admin and MNT, and then it will be able to accept the connections from the secondary nodes. But before we do that, let's jump back to the ISE and see what settings have been added. So first of all, if I refresh the screen, before it was a standalone, but it has been promoted to the primary node, right? And then if you go to the certificates, again, before we only had a single default self-signed certificate, but it's only tied to the admin function. And I have the Let's Encrypt ACME certificate, tied for .1x, as well as Radius DTLS and any of the end user facing portal pages. And if you look at the certificate, you can see that we have the root certs as well as the intermediates. And this certificate is valid for 3 months from now. And it's a wildcard certificate. And in case you didn't notice, I mean, everything that I'm doing and demonstrating here today is going to save you a lot of time, right? Because you don't have to sit and kind of set up everything manually. It can be automated. And the part about the certificate is that this can be very complex depending on how your kind of a team is organized. But using this automated tool, you can get a free like, signed certificate that you can use for the end users. And so in this case, it not only saves you time, but also cost for managing certificates. The part is so I have some users I've created now. I have some users as well as some matching, user groups. And if I go to the external identity store, as I mentioned, I have the 2 domains. And for the auth.net, I actually joined to the domain using the API. And I should show the operational. And I can even test the user to make sure that the join process is working. If this works, you'll see the success, as well as the groups and any attributes for this user. Okay, so it shows success, and there are different groups that this user is a member of, and all the attributes that corresponds to this user. And the other part is the network devices. So as you can see, all the network devices have been created that I'm using on my network. And if you go back to the policies, you'll see that there's all the policies that I have configured using the API. So 3 SSIDs, secure, guest access, and PSK, as well as the VPN access and the wired access. And going back to the admin, remember that we have created repository. So again, S3 backup repository has been set up automatically for you. And let's go to the deployment before I show the rest of the playbook. Okay, so what I'm going to do is continue this process. I have a timeout so that I can show you in steps. But I'm going to continue. And what this code is going to do is keep adding the rest of the ISE nodes into the primary node. So it will add starting with the MNT, the backup admin and backup MNT, and then rest of the 3 PSN nodes. Now, one of the things that I'm doing is, after this is done, we need to take off the PSN persona or function from the admin node. But I'm just giving a long timeout because once this, secondary nodes are being added, the replication starts and it takes about 20-30 minutes to finish. So that's why I have a long timeout before deleting the PSN function from the the admin node. But to just show you, if I refresh, as you can see, the secondary nodes are being added. The ISE2 is the secondary admin and MNT, and we have the 3, 5, and 6. Again, 4, 1, it's not working. So you'll see 5 nodes in total in a deployment in the synchronization state. And again, it's going to take about 20 minutes for all of these nodes to be, fully synchronized and be able to authenticate the users. But for now, since we have added the users to the, primary admin node, I left the PSN persona function in there, right? So we should be able to test users. So let me do a quick test of the authentications. So, okay, so this is a test tool. And let me make sure that I have the right IP address of the ISE nodes. Okay, so it's 1.46. So you don't do this on the real setup, right? Because it's an admin node. But since I don't want you to wait for the PSNs to come back up, I'm just using the admin nodes as a testing setup. So I'm going to send the authentication request. And as you can see, the authentication was successful, and the user was authenticated. And one thing I want to show you is the actual certificate, right? I mentioned that we have installed the Let's Encrypt server certificate, and it shows the actual server certificate in the process. And if you click on it, it actually shows that it's signed by 0SSL instead of the self-signed certificate. So we know that proper certificate that we have embedded, the wildcard, is in effect. Before I close out, let me just test a few more. I'm going to give a different MAC address. Okay, so this user also works, and I'm going to fail the next user just for fun by adding some other SSID name. And as you can see, this one got rejected because I purposely did that. So at this point, if we want to go back to ISE, we should be able to see the, let me see if it's done. Yeah, it takes, it's going to take a few more minutes. And the other thing is when it's synchronizing like, 4 or 5 nodes, it's really busy. So sometimes the live log page may not show up, but we'll check it out. So as you can see, we tried 3 times and there's like 3 endpoints that's been added. And if you go to context visibility, we have the 3 MAC addresses, as well as the 3 matching users. And as you can see, one of the users failed the authentication, right? And then if I go to the operations, again, because of the synchronization, this may come up in time or it may not, but we'll check, we'll give it some time. Yep. So like I mentioned, because of the heavy process right now that's put on this node to replicate everything to the secondary nodes, a lot of times this may not come up right away. But hopefully this gave you an idea on how to automatically set up ISE deployment, not just like one node, right? For demonstration purposes, it was 6 or 5 nodes, and regardless of whether it's 5 nodes or 20 nodes or 60 nodes, the amount of time and effort it takes is about the same. You should be able to bring up in a relatively short time frame. And let me just jump back to the slides. Let me just try one more refresh just to show you. Okay. Okay, it's still really busy. So, okay, so kind of wrapping up right now. So we have some of the resources. Again, if you want to go to community page to get any help, that's the best place to go. We also have, if you want to review some of the older videos that we had, you can go to the YouTube channel, as well as the webinar folder or link here. But if you want to try out the code yourself, you can look into the ISE API, as well as the ISE DevNet link. And the code that I was running for testing and demonstration purposes, I'll be posting them in this GitHub link, so that you can try it out on your own.